Number 43 here is you're given a picture. So we're given a picture that looks roughly like this, 30 degrees, 4 and 3. What I'm going to do is I'm actually going to add, we're asked to find the sine of alpha, which seems like it would be a hard question, but not if you add this little line segment here. So if I do that, I have a 30, 60, 90 triangle. So I know that the hypotenuse is going to be 2x, which makes the side opposite 30 be equal to x, which is 2. And then on the left-hand side of this picture, I now have a right triangle, and I'm looking for the sine of alpha. So the sine of alpha is just going to be 2 over 3. So it looks like it might have been a calculator question, but definitely not. That's a really quick question. The next one is 44, and we're given some rectangular solid. We know the sides are 8, 4, and 1. We're looking for the longest line segment whose endpoints are 2 vertices of this solid. So that's actually going to be a diagonal of this box. But the question is, what diagonal? So if I go from like bottom left to top right, that's going to be the longest diagonal that you can get. You can get it multiple ways, but it's still the longest. So I'm also going to have to go along the bottom there. And if you look at it, that's actually a right triangle. So if I could figure out that orange segment, then I would be able to use the right triangle. So let's label up the sides 4, 8, and 1. And it's drawn kind of to scale, not really. But even if I hadn't drawn it to scale, this would still work. So to find the orange segment, I use that right triangle that has 4 and 8 as the legs. So that's going to be square root of 8 squared plus 4 squared. And then you should definitely use a calculator for that, but it's going to be radical 80. And then I have a right triangle that has a leg of radical 80, a leg of 1, and the hypotenuse is what I'm actually looking for. So that's going to be square root of 1 squared plus radical 80 squared, which is square root of 81, which is 9. And so the answer is B. Let's move ahead to number 45. So for 45, it's this weird log question. We want the log base A of 45. And we know that the log base A of 3 is x and the log base A of 5 is y. And there's probably a reason for that, so let's just change 45 up. So I'm going to factor it into 5 times 3 squared. I'm going to use properties of logs to break this up. So this one you can do on your calculator, and I'll show you how in another video, but you can definitely do it this way, which isn't all that difficult. But you have to know the properties of logs. So you bring down the exponent there. And then I'm told in the original problem that log base A of 5 is y, and log base A of 3 is x. So I get y plus 2x, which is option A. All right, let's move on to number 46. 46 is a good question. You are told that you have an angle theta, and the sine of theta is t, and theta is between 0 and pi over 2, which means it's just in a right triangle, and we have to find the tangent of theta. So since sine of theta is t, I'm going to label these sides t, and 1 is the hypotenuse, and the missing side is square root of 1 minus t squared. And then just based on the picture, what's the tangent of theta? Well, tangent of theta is going to be opposite over adjacent. So I get that, which is option B. So we got it. Let's move on to question number 49. So remember, anything I skip, I'm doing on a calculator. 49 is about matrices. So I am told that matrix A is an m by n matrix, and B is a n by p, and m, n, and p are distinct numbers. So what I want to do is figure out something. So the first, it's one of those 1, 2, 3, and then blah, blah, blah type questions. First thing, number 1, says that BA does not exist. So let's see if BA exists. B times A, I'm going to be doing an n times p, n by p times an m by n. So the only way you can multiply matrices is if those two middle numbers are the same, so these numbers, they're not the same, which means that this product doesn't exist, which means that number 1 is actually true, because number 1 says the product does not exist. So number 1 is true, so I'm going to cross out anything that doesn't involve number 1, so that's going to be B and C are gone. So B and C are no longer options. So let's move on and see what we get here. Next one, I have to multiply AB. So 2 and 3 are both about AB. So one of them says that you can do it and you'll get an M by P. The other one says you can do it and you get an N by N matrix. So the real question is, what type of matrix am I going to get? Because you can definitely multiply them. So you can do it because those middle numbers are the same. And then the result is always a outer left by outer right matrix. So that's going to be an M by P matrix. So that makes number 2 true, which means number 3 is out. So I need the option that includes 1 and 2, and that is option D. So that's the answer. All right, and let's take a look at number 50, the final question. So it's about complex numbers. So you're not given any coordinates, but what I'm going to do is I'm actually just going to make them up. Because if it always works, it's got to work for the ones that I make up. So I'm going to say that that's equal to w. And then the problem says to do negative I times w. So negative I times w for me is going to be negative I times negative 2 plus 3i, which is 2i and then minus 3i squared, but I squared is negative 1. So it's 2i and then plus 3, which is 3 plus 2i. So if I plot this, that gives me that point. And there's only one choice in the options. If you look at the grid that you're provided, there's only one answer that could possibly be it, and that would be A. So that's the end of that test. I'm going to make all the calculator videos for you to watch. I don't know what order you're watching these in. But anyway, I hope this was helpful, and good luck.